In this video, I'm going to show you how to make Magnalium metal, and if you're wondering why you'd ever need such a thing, I'll give you 3 reasons why. Need I say more? Stay tuned. Magnalium is an alloy of 50% aluminum and 50% magnesium, and it's a key component in those 3 effects I showed earlier. Here I have 42 grams of magnesium, and that's my limiting factor. Then I'm just weighing out some aluminum pop cans and making sure I have an excess, as I'm going to melt these down into a purer ingot. Since aluminum has a melting point lower than that of steel, a simple thin steel crucible will do, though, as you'll see later, this gave me some issues. There are equal parts aluminum and magnesium. I'm going to melt this first, toss this in, and hope it doesn't all catch on fire. Shoot. Now, if you were using a kiln, this could work as you could fine-tune the temperature, but that forge made quite a mess of things. Okay, the thin crucibles of like a soup can simply won't cut it if you're doing coal. If you had like a kiln, you could probably do it because you could fine-tune the temperature. But I have a propane bottle here, so that should be able to take the temperature. I've got the aluminum in there already. Turn on the power to the forge. Honestly, I'm not quite sure why I didn't just use a propane bottle in the first place. Now I'm going to let that melt, put in the magnesium, stir it around just a little bit, throw in a bunch of charcoal, kill the power, and hope all goes well. I'm going to throw some safety glasses on. Speaking of safety, if you're cutting open a propane bottle, make sure of 2 things. 1, that it has no propane left in it, and 2, that you drill a hole and then fill it up with water to purge any remaining gas so you don't have an explosion on your hands. Just because a bottle doesn't hiss gas when you open the valve doesn't mean there's no propane inside, and taking an angle grinder right to it is a dangerous endeavor. You can see now that the aluminum is essentially completely melted. Okay, so we are all set to throw in the magnesium. The magnesium is in, my safety glasses are on, and I am scared. My stated fear comes from several safety concerns that should probably be addressed. The first is that a coal forge does have the ability to melt that crucible, and that happening with a highly reactive liquid metal is a really bad situation. And any unexpected spills aside, this metal is incredibly reactive. It's a liquid state of magnesium, and the aluminum calms it down just a little bit, but it still needs to be treated with respect. Upon contact with air, the liquid metal will rapidly oxidize at some several thousand degrees. Also, upon contact with water, it will react so violently that it may spew liquid metal and cause serious harm. Which is why it's really perplexing that these firefighting professionals put water on a magnesium fire. But I think they learned that lesson. Anyways, back to the video. Okay, it's in there. It's starting to melt. You can see that it is reacting. It's starting to burn. I'm gonna kill the heat. And now let's see, all right, we do have completely liquid metal. And it is very reactive. As you can see, it's burning on the end of the stick when it comes into the open air. Now, what I'm going to do is carefully take it off the heat and put it out here. And now throw a bunch of charcoal on top of it. This is charcoal dust and it's starving it of oxygen. Nice bed of coals. I got that done really quickly. Once it cooled down enough that it wasn't lighting things on fire, I knew that it was probably cool enough to put in the snow. Again, you want to keep this away from water. But I think it's cool enough now that that doesn't matter. This will be cool enough to handle pretty soon. You'll know you've had a successful run if your alloy has this incredible luster to it. Also, if it is incredibly brittle. Man, that alloy is just so beautiful. Anyway, it looks like we got about 68 grams of the alloy, which is a bit of a loss from the theoretical about 80 or so that we should have got. But all things considered, for a run of this size, that loss isn't too terrible. And finally, I'm going to test it with a burn test. I mixed up some very crude flash powder here, but I only ground it up with a rolling pin, so it's not very reactive. But it works nonetheless. Anyway, that's all I have for you today. Stay tuned for some projects including this material. If you have any questions, feel free to ask me in the comments below, and you can find video credits in the description. I thank you for sticking around to the end, and I hope to see you next time. Thanks.